Hello everyone, I'm Dylan Kiefer G. Taklas and with me is my groupmate LG Stanley Sardan. Today we'll be discussing magnetic particle inspection or MPI. This is one of the most widely used non-destructive testing methods for detecting flaws in metals, especially in industries where safety and reliability are crucial, like aviation, automotive, and construction.
We'll guide you through how MPL works, what it's used for, its advantages and limitations, and why it's so important in keeping our infrastructure and equipment safe.
Magnetic particle inspection is a technique used to detect surface and near-surface defects in ferromagnetic materials. These are metals that can be magnetized such as iron, nickel, and steel. The main idea is simple. When you magnetize a metal part, any cracks or discontinuities will disturb the magnetic field. This disturbance, called magnetic flux leakage, causes magnetic particles applied to the surface to gather the flaw, making it visible. MPI is popular because it's fast, relatively easy to perform, and doesn't damage or alter the tested part. This makes it ideal for routine inspections in factories, workshops, and even on-site in the field. Let's break down the process. First, the surface of the metal part is cleaned to remove dirt, oil, or paint that might hide defects or block the magnetic field. Next part is magnetized using equipment like a magnetic yoke or coil. Once the part is magnetized, magnetic particles either in dry powder form or suspended in a liquid are applied to the surface. If there's a crack or flaw, the magnetic field will leak out the point, and the particles will cluster there. This makes the defect visible, either under normal lighting for dry particles or under ultraviolet light. If fluorescent particles are used after inspection, the part is usually demagnetized and cleaned to remove any remaining particles. There are two main types of MPI, the dry method and the wet method. The dry method is best for rough surfaces or when working outdoors, while the wet method, especially with fluorescent particles, is more sensitive and often used for detecting very fine cracks in critical components like aircraft landing gear. It's important to remember that the MPI only works on ferromagnetic materials. Non-magnetic materials, metals like aluminum or copper, cannot be inspected using this technique. This is why MPI is so common in industries that uses a lot of steel and iron, such as shipbuilding, railways, and heavy machinery manufacturing.
Now let's talk about where MPI is used. One of the biggest applications is the aerospace industry, where safety is absolutely critical. MPI is used to inspect landing gear, engine components, and other structural parts for tiny cracks that could cause catastrophic failure if left undetected in the automotive industry. MPI is used to check axles, crankshaft, and gears for defects before they installed in vehicles. In construction and infrastructure, MPI helps ensure the safety of bridges, trains, and pipelines by detecting cracks on wheels and metal joints. Even in the oil and gas industry, MPI is used to inspect pipelines and storage tanks to prevent leaks and environmental hazards. MPI has several advantages. It's quick, cost-effective, and can detect very small surface cracks and might be missed by visual inspection alone. It's also portable, so inspection can be done on site without moving large equipment. However, MPI does have limitations. It can only use ferromagnetic materials, so it's not suitable for all metals. It also mainly effective for surface and near surface defects. Deep internal cracks might not be detected. The orientation of the might not be revealed. Finally, after the inspection, the part needs to be demagnetized, which can be exhaustive in process.
Despite its limitation, magnetic particle inspection remain one of the most trusted and widely used methods for ensuring the safety and reliability of critical metal components. Its ability to quickly and accurately detect flaws helps prevent accidents, saves lives, and protect investment in infrastructure and machinery.
By using NPI, industry can catch problems early, avoid costly repairs, and most importantly, keep people safe whether they're flying in an airplane, driving a car, or working in factory.
That's our overview of magnetic particle inspection. We hope you've learned how this technique works and why it's so important in today's world. Thank you for watching. If you have any question or want to learn more, feel free to ask Stanley Stardon. Check out the video links in the description.
I've been the prey, screaming who could ever leave